Okay, we are looking at 5.3. 5.3 starts on page 211 with some key ideas and some strategies on how to solve radical equations. I want to just take a second and talk about simplifying square root terms. To simplify a square root, you take out anything that is a perfect square. That is, you take out front anything that has two copies of the same factor. So for instance, we um, look at the square root of 4 and we simplify that as 2. The square root of 49 is 7. The square root of 225 is 15. One thing to note is that the value of simplified radical is positive. So in this case, when we say the square root of 4, we just say that's 2. We don't say plus or minus 2, and this is why. Well, either of positive 2 or negative 2 might have been squared to get 4. The square root of 4 is defined only as the positive option. However, when you solve the equation x squared equals 4, you're trying to find all possible values that might have been squared to get 4. But when you are simplifying the expression, the square root of 4, the only answer is 2. This positive result is called the principal root. So we're really only looking for the principal root here. The only time we take both cases is when we're dealing with x squared or quadratics, okay? So that's something that I know. So when we're dealing with quadratics, we have two answers, all possible. But when we're dealing with radical expressions, we only take the principal or the positive. So that's something that might try and throw you for a loop, but just to clarify that. Okay, let's get started on page 212. So what we're going to do is we're going to solve the square root of y minus 1 plus 7 equals 13. Okay, so what we're going to do is we're going to isolate the radical. We're going to make it be on a side all by itself. So we're going to subtract 7 from both sides, and we get 6. And now what we're going to do is we're going to square both sides. So we're going to raise each to a power of 2. The reason I chose squaring had to do with the index here. If there was a cube there, I would cube both sides. Okay? So we get y minus 1, because when we square a radical, we just get the radicand. And 6 squared is 36. And now we're just isolating 6. Or isolating, sorry, y. So we add 1 to both sides. We get 37. Okay? Now we're going to state the restrictions on y so that the radical is a real number. Well, we know that y minus 1 must be greater than or equal to 0. The reason we know that is we have a square root, and the square root of a negative number doesn't make sense. So y minus 1 must be greater than or equal to 0. So y must be greater than or equal to 1. So let's look at this. Is 37 greater than or equal to 1? Yes. So that looks like we may have the correct answer, but here it asks us to verify. So to verify, we take our answer of 37 and we sub it back in to our original equation. Okay, so what we're asking is the square root of 37, because that's where y is, minus 1 plus 7 equal to 13. Well, is the square root of 36 plus 7 equal 13. And here's where that principal square root comes in. The square root of 36 we say is 6. We don't say it's positive 6 or negative 6. In this case, because we're dealing with radical equations and not quadratics, we just take it as 6. Okay? So does 6 plus 7 equal 13? Does 13 equal 13? Does the left side equal the right side? Yes, indeed it does. Okay? Good. Let's move on to the next question. So now they say that we have an extraneous root. An extraneous root is one that does not fit the restriction or doesn't make sense. And because you square both sides, sometimes you get two roots and one root doesn't make sense. So you always got to check these. So what we're going to do is we're going to solve the equation m equals the square root of 2 minus m. And what we're going to do is we're going to square both sides. So when we square this side, we get m squared. When we square this side, we're just left with the radicand, 2 minus m. So what we're going to do is we're going to set this equation to be 0 so that we can use some of the tools we used in last unit. Okay, we're going to get we're going to bring everything over to this side. So we get plus m, and we get minus 2. So there's a couple ways we could solve this. We could factor, we could complete the square, we could graph, we could use the quadratic equation. When I look at this, I see that the easiest way to do this is to factor. So I need two numbers that multiply to be negative 2 and add to be positive 1. So that's m plus 2 and m minus 1. And there we go, I have this factored. Now to solve, I need to set each of these factors to be 0. So I get m plus 2 equals 0 and m minus 1 equals 0. In this case, m equals minus 2. In this case, m equals 1. Okay, now, so those are my roots, but I need to check that these are extraneous. I need to double check that these are actually correct. So here's my check. I'm going to sub back into my original equation, which is m equals the square root of 2 minus m. So does negative 2 equal the square root of 2 minus negative 2? Okay, principal square root coming in here. Negative 2 equal to the square root of 4, because 2 minus negative 2 is 4. No, it does not. The principal square root of 4 is just 2. So negative 2 does not equal 2. So this is extraneous. In other words, what we're going to do is we are going to completely throw this out. I don't know how to spell the word extraneous, I realize when I start writing. Extraneous. There we go. Okay. Let's try this one. 1. Does 1 equal the square root of 2 minus, remember it was m equal the square root of 2 minus m. Does 1 equal the square root of 1? Well, the square root of 1 indeed is 1. So our left-hand side equals our right-hand side, and this is true. Okay? Part C said state the restrictions on the variable so that the equation involves real numbers. Well, I'm going to do that right here in a different color so we can look at it. I know that the radicand must be greater than or equal to 0. Okay, so solving for this, I'm going to add m to both sides. I get 2 is greater than or equal to m, and then I'm just going to write the m first. So m is less than or equal to 2. Is that right? Yeah. So looking at our equations, m must be less than or equal to 2. Both of the roots actually fulfilled that. And then we just double check that the one that we actually said was right also fulfills that. So we're okay. Okay, next question. Solve the radical equation square root of 2x plus 5 equals 2 the square root of 2x plus 1x is greater than or equal to 0. So what we're going to have to do is we're going to have to square both sides. And we might have to do this a couple times. So this is a little more work when we have a radical expression on both sides. So I'm just going to rewrite the equation. So my first step is I'm going to square both sides. Okay, left-hand side, easy. When you square a radical, you just get the radicand. Okay, this is where the mistakes are made. Here I have a binomial. I have one term, two terms. When I square a binomial, I should get a trinomial. The way that I square a binomial is simply to FOIL. Okay? So I'm actually going to rewrite this a second time to double check that I do not make any foiling errors, because that would be embarrassing beyond belief, wouldn't it? Okay, so my first term, 2 times 2 is 4. The square root of 2x times the square root of 2x is just 2x. So I did my first FOIL outside, so I get plus 2 the square root of 2x, because it was just times 1. Outside. Inside, I get that same term again. And last, I get 1. No brackets there. Okay, so now I just need to simplify this side. 2x plus 5 is equal to 4 times 2x is 8x plus 2 root 2x, and 2 root 2x I have 4 root 2 4 root 2 x's, and I have a plus 1. So now what I want to do is I want to isolate this radical right here and get everything else on the other side. Okay, so I'm going to subtract 8x from both sides. So 2x minus 8x is negative 6x. 5 minus 1 is 4. And on this side, I'm left with 4 root 2x. Okay, and now I'm going to square both sides to get rid of this radical. Oops. So square both sides. Once again, here I have a binomial, so when I square it, I'm going to get a trinomial. So 36x squared first. Outside and inside are going to be the same. It's going to be negative 6 times 4, which is negative 24x, negative 24x. And then the last term is going to be 16. On this side, when I square this, 4 squared is 16, and the radical squared is just the radicand. Okay, so now I have some simplifying to do here. I have 36x squared minus 48x plus 16 is equal to 32x. I'm going to set one side to be 0 so I can use my quadratic skills. I'm going to subtract 32x from each side. So 36x squared minus 48x minus 32x plus 16 is equal to 0. Well, 48 minus 32, I think is 80, right? 48 minus 32, yep, is minus 80x plus 16 is equal to 0. So now I'm just solving equations. Well, I can see that there is some common factors that I could get out of here. And I think the greatest common factor between 36, 80, and 16 is 4. I know 2 is, but I'm pretty sure I can do 4 as well. So I'm left with 9x squared minus 20x plus 4. Okay, so now what I'm trying to do is I am trying to solve this. And the way I can solve this is I can factor, I can complete the square, I can use the quadratic equation. And you can use, I could also graph. You can use whatever strategy you want. I'm going to try factoring because I like factoring. So I need two numbers that multiply to be 36. Remember, that's 9 times 4. And they have to add to be negative 20. Oh dear. What two numbers are those? Okay, I think they're 18 and 2. So if we have negative 18 and negative 2, right? Because that would add to be negative 20 and multiply to be positive 36. Okay, so I can divide both sides by 4, first of all, and that gets rid of my 4. Okay, because 0 divided by 4. And then I'm going to rewrite this as 9x squared minus 18x minus 20x plus 4. So all I did, oops, minus 18x minus 2x. So all I did is I rewrote 20 as these two numbers. 20 is minus 18 minus 2. Okay, and now what I'm going to do is I'm going to group. Factoring by grouping. So the greatest common factor between 9x squared and 18x is 9x. I'm left with 8 minus 2. The greatest common factor between negative 2x and 4, I'm going to take out a negative 2. The reason I took out a negative 2 is then I get x minus 2, which is the same factor here. Okay? Equals 0. So then I get 9x minus 2, right? Just these two terms. And then I get x minus 2 is equal to 0. So I get 9x minus 2 equals 0. I set both factors to be 0. In this case, I get x equals 9x equals 2, x equals 2 ninths, and here I get x equals 2. Okay, so I have two possible solutions to this equation. That was a lot of work. But what I need to do is I need to check. I need to double check that those solutions are correct. Okay? So what I'm going to do is I'm going to sub these back into my original equation. So should we start simple? Let's start with the 2. What was it again? X equals 2, x equals 2/9. Okay, let's try this out. X equals 2 into our original equation. The square root, this is our original equation here. The square root of 2 times 2 plus 5 is equal to 2 times the square root of 2 times 2. So 2 times 2 is 4. 4 plus 5 is 9. So does the square root of 9 equal 2 times the square root of 4? Does 3 equal 2 times 2? Does 3 equal 4? No, no way. So this is reject. It's extraneous, not a root. No way. Wrong answer. And the reason we got a wrong answer is because we did some squaring. Every time we square, there is an opportunity for an extraneous root to come out. Okay? Now let's look at x equals 2/9. Okay? And we're not even scared of fractions, so don't worry. X equals 2/9 into our original equation. Okay? So we have the square root of 2 times 2/9 plus 5. Does that equal 2 times the square root of 2 times 2/9? Not even scared. Don't worry about it. Okay, so I get the square root of 4/9 plus 5. Is that equal to 2 times the square root of 4/9? Well, I kind of like this side going on over here. Okay, let's look at how do we simplify this expression. What we have to do is we have to make a common denominator. So we're going to change this 5 into ninths. Well, 5 is the same as 45/9. Okay? So I have 4/9 plus 45/9. That's a total of 49/9. The square root of 49/9, is that the same as 2 times the square root of 4/9? You square root the top and you square root the bottom. So that's 2 times 2/3, because the square root of 4 is 2. The square root of 9 is 3. Okay. Okay, I realized I didn't copy the entire equation. I forgot this plus 1 all the way down. I knew I was coming to a wrong answer, so let's just add that plus 1. Plus 1. Sorry, that was just a copying error. So I just copied this left side wrong. Okay. The square root of 49/9, the square root of 49 is 7, the square root of 9 is 3, so this is just 7/3. 2 times 2 is 4, so we get 4/3 plus 1. Well, 1 is just 3/3. So I have 7/3 is equal to 4/3 plus 3/3 is 7/3. Yes, this is a correct solution.